Okay, what we're going to do now, all right, is before we continue any further with the chemistry unit, what did we talk about last time? Did you look at the web? I'm having a hard time actually uploading both of them, but I'm working on it. But what did we talk about last time in class? Do you remember?
Physical.
Yes, Laura.
Intensive and extensive.
Intensive and extensive physical properties. Excellent. Excellent. We talked about physical properties. We introduced maybe a little bit of chemical properties, etc., right? What's a chemical property? Does anybody know what the definition of a chemical property would be? Everybody, I think, how many people are pretty comfortable with physical change and physical properties? Freezing, melting, right? You're cool? Okay. What's a chemical property, though? What's a chemical property? When would chemical properties, when could you identify a chemical property? Like hydrogen. Hydrogen's a gas at room temperature, but that's a physical property. When would you be able to talk about a chemical property of, say, calcium or hydrogen, oxygen, water, right? What else? Name me some common things. Iron, right? Gold, excellent. What are some other common things? What is it? Silver, excellent. I use the word that people take for granted. What does the word substance mean? What does the word substance? Don't look it up. I want to know what you think. What does the word substance mean? How many people have ever heard of, seen it written, the word substance? Raise your hand. How many people actually can define it? Raise your hand. Nobody. They all raise their hand. Yes, can you define it?
I knew because I learned about it before, and it's about matter.
It's about matter. Excellent. That's true. Substance is matter. Yes. It's a specific word, though. Matter is very general, don't you think? Yes? Matter simply means not energy. Everything, right? It's either energy or matter, right? So it's not energy. So if it's not energy, it's matter, right? Yes? Yes?
A liquid of some sort?
Liquid? Right? Is that what you're saying? Substance is liquid?
Yeah.
A substance can be liquid, yes, absolutely. Are all substances liquid?
No.
No. Do you think that all substances are liquid? No. But some, they can be liquid, yes.
They're the particles inside of solid, liquid, or gas.
There are particles inside solid, liquid, or gas. Yes, that's correct. However, all matter is either a solid, liquid, gas, or what's the fourth state of matter? The most prominent state of matter? Plasma. Do you ever hear of like the word star or the sun? That's plasma. Most dominant form of matter in the universe is plasma. Yeah. So, yeah, all matter is either in one of those four forms, but what's the word substance? Nobody can identify. Everybody raised their hands when I asked them if they knew what a substance was. Or have read the word substance, have heard the word substance, have even used the word substance, but no one can define it. Isn't that interesting? Scott?
I think substance is maybe a mixture of matter.
A mixture of matter. Okay. Yes.
Something you can actually touch.
Something you can touch. Okay. Yes?
Is it like a matter or material that has properties or?
You're getting there. You're getting warmer. She said, is it something that has properties? Yes, that's correct. All right, shall I tell you? Are we done guessing? Yeah? All right, good. A substance is either a compound or an element. It is pure material. It is material that has one set of physical properties that defines it. It is not a mixture that can be separated physically. It is a collection of one particular element. Gold. Gold is a substance. Gold is a pure material made of only gold atoms. Gold is an element. Elements, one particular element, is a substance. Substance is pure. It's uniform. A compound, like water, is a substance. So it has to be either an element or a substance. What two types of compounds are there? There are molecules, which are covalent bonding, which we'll talk about. There are what we call formula units, which are compounds that have ionic bonds, yes? So a compound is a pure material, only water, only sucrose, only ammonia, only binary nomenclature, only calcium bromide, only iron 3 oxide. Those are substances, those are compounds. Yes? A chemical reaction is something that helps define what a chemical property is. The chemical property of a substance, of a compound or an element, are those properties that are only obvious when that substance comes into contact with another substance. When oxygen and hydrogen come together, they explode to form water. That chemical reaction will help you define the chemical properties of hydrogen and oxygen. Water. If I take calcium and I put it into water, I produce heat and I produce bubbles. Those bubbles are actually hydrogen gas. So here are three chemical properties. Explosions, heat given off. An explosion, usually heat is given off, right? So that's kind of like one. Something that gives off heat is probably a chemical reaction. It's a chemical property. Effervescence. What does the word effervescence mean? What does that mean? Effervescence. How do you spell that? I want you to look that up. Effervescence. How do you spell effervescence? It's a hard word to spell. Greta, we have, she has a Mac computer. Excellent. What do you got? Well, that's part of the challenge of looking something up. Oh, Victoria, you have it. What do you have?
E, F, F.
E, F, F.
E,
E,
R,
R,
V,
V, as in Victoria.
yes, E,
E, a lot of vowels. I'll buy another vowel.
S,
S, a consonant. S,
C,
C,
E,
E, wow.
N,
N,
C, E.
wow, that's a big word, huh? What does it mean? Effervescence. Greta.
Like that is all bubbles.
Yeah, the production of bubbles, fizzing. Alka-Seltzer, Plop, plop, fizz, fizz, oh, what a relief it is. That was a song when I was a kid. That was Alka-Seltzer commercial. Plop, plop, fizz, fizz, oh, what a relief it is. Effervescence. That can be a sign of a chemical reaction. When you put calcium into water, you produce effervescence, bubbles of hydrogen. You produce heat. I can explode the hydrogen because it's in close proximity to oxygen in the air, right? Yes? Right? Okay. But all of this information came from somewhere. I'm getting to my point. It all came from somewhere. And it came from a lot of hard work. It came from people who might have been ostracized from society for talking about things that were against the status quo, against society. I don't like her. She thinks science. No! Burned at the stake. Galileo under house arrest for the rest of his life. Scientists. At one time in Europe, you had to be wealthy, politically corrected, and have a lot of money if you wanted to do, and be smart if you wanted to do science, and have an education. Because it wasn't safe to do it. It was unsafe. Do you understand a little bit more where this is going from and why I spent a half an hour, 45 minutes talking about things? Makes a little bit more sense now? Yeah. We have to thank scientists. So it's important to know the scientists. Where did this come from? And it's more than just notes on a board. Democritus. He came up with the term atom, meaning indivisible, for instance. Louis de Broglie. What did he come up with? What did he look up? What did he invent? What did he postulate? What did he theorize? What did he do? John Dalton. Kinetic theory, molecular theory of matter. Yeah. Anybody know what John Dalton did? Yes. Oh, all the hands are raised. Yes.
Me?
Sierra, yeah.
Okay, so he developed the theory of
Atomic theory.
and color blindness.
And color blindness. He talked about color blindness. That's interesting. Anybody else? John Dalton, yes.
He also made the Dalton theory
Dalton theory
about atoms.
about atoms. Excellent, I like that. How about Ernest Rutherford? Yes.
He had the gold foil.
The gold foil experiment. Excellent. The gold foil experiment. You know what the gold foil experiment was like? Can you imagine taking a giant cannon, shooting it at a piece of toilet paper, and have the cannonball bounce back?
What?
Yeah, that's what it was like, the gold foil experiment. He shot what they call alpha particles at gold foil, and some of the alpha particles bounced back. And some of the physics principles that we know of today relative to momentum and forces, that would be like shooting a cannon at a piece of toilet paper and having it bounce back and hit you. It's amazing stuff. How about Hantaro Nagaoka? Nantara Nagaoka? No? Interesting fella. Not widely studied in the Western world. Very, very critical and very important. How about James Chadwick? James Chadwick, anybody? J.J. Thomson, without the P? Yes.
He was an English physicist.
He was English, good.
He discovered electrons.
Electrons. He discovered electrons. He found that they exist. What was one thing that he used? Can you name one instrument that he used? Yes.
Glass tubes.
glass tubes called cathode ray tubes. Do you remember, are you too young to remember the big giant televisions that are like really big? And they like, you watch it, but behind it is this enormous screen, enormous television behind it. It's like 2 feet thick. That's called a cathode ray tube. That's how televisions used to work. Cathode ray tube. I can't believe I'm having this conversation. Cathode ray tubes. They don't know what a cathode ray, they don't know what a big television is. How many people have ever seen a giant television? Oh, you have? Okay, good. Yeah. That's a cathode ray. That's what they all were like. That's what they all were like until the current ones came out. So, T. Darcy Chemistry, that's a YouTube site. These are scientists. I filmed movies like this on that site. So you might want to read that site. You might want to look at that site. Next week we'll have a quiz on these guys. We'll talk about them. We'll talk about those gentlemen. We'll talk about them on Monday, right? Maybe Wednesday we'll have a little quiz. And all you'll have to do is to recognize a few things that they did. So for homework, I want you to write just 3 things about the atom. The atom. 3 things that each of these people did relative to the atom. Okay? Yes? 3 things. Okay? Easy? Not hard? You can go to my site. You can go to YouTube and put in questions about them. You can look up Google. You can find a book. However you want to do it. In this day and age, it's something that's easy. Now, next week I'm going to give you a several page, 2 or 3 page, whatever you call it, sheets of paper, and you're going to have pictures of scientists. Because it's not only important to know these, what they did, but you should know what they looked like. Don't you think that's important? You should know what they look like. And then you're going to pick one scientist. Nobody can pick the same. You've got to pick one scientist. We'll have like a lottery picking scientists.
There's not enough on the board.
No. There's not enough on this board, but I have a sheet with plenty. And you're going to pick a scientist and you're going to write just one page on the scientist. Clear? Yes? Got it? And question, yes?
Is J.J. Thompson Joseph John Thompson?
J.J. Thompson, I believe, is Joseph James. Yes, correct. Yes?
Can it be like any scientist? Like
No, the scientist that I give you. It has to be the scientist that I give you. Unless, hey, everything's a negotiation. Unless you want to come up with a negotiation and try to convince me otherwise, but I have absolute veto power. Fair? Okay. All right, are we off? Are we done? Yes? We're off.